Awesome. Thanks, Jürgen. Hello, everyone. Welcome to the 5th edition of Cloud Native Computing Linz meetup. Here in the first page, we have our Twitter handle. So if you have a Twitter and if you use it, please follow us, tag us if you're sharing something regarding the presentation today, and help us grow in the community. You can also follow our page on the community cncf.io/links. And yeah, and the meetup page where I guess most of us are members already from the group. Before we start, I'm gonna go over a couple of slides and then we start with Karthik at 5:10, 5:15. Then we're gonna do a break in the middle between the two presentations with some networking. We're gonna follow the same activity that we did in the previous one that I personally liked very much. Some breakout sessions with some funny icebreaker questions just to get to know each other a little bit, and nothing mandatory. You don't need to share personal stuff if you don't want. And then at 6:10, we go back to another presentation with Michael. And about 6:50, we just do some closing, and yeah, that's it. So we follow up a code of conduct, the Berlin Code of Conduct, that mainly says that everyone is welcome. Doesn't matter your level of knowledge, your gender, where you're from. So everyone is welcome. And that extends also to the presentations. So whenever you have a talk and something that you would like to share with the community, please reach out to us. We would love to hear from you, and maybe you don't have a full presentation, it's no problem. We can discuss a little bit and maybe come up with a type of presentation that fits you. And if you have something to share, yeah, don't hesitate in contacting us. I'm Juliano Costa. I'm a software engineer at Dynatrace, and my Twitter handle is jcosta_89. I'm one of the co-organizers of the meetup with Jürgen. Jürgen, would you like to introduce yourself?
Yeah, sure. Hi, everyone. My name is Jürgen. Yeah, together with Giuliano, I'm the co-organizer of this meetup. Always happy to hear new, exciting projects from the cloud native community. Or also today we have like a one-man army joining, and we have a very interesting talk also today with Karthik that I was already had the opportunity to work with. So I'm really excited for today's edition. And yeah, as Giuliano said, if you have anything you want to share, just let us know, and we are happy to also give you the stage to present your projects.
Thanks, Jürgen. So we would like to thank our sponsor, and I have something, sorry, not here. I have something that I would like to talk about the sponsor. And our sponsor is Chaos Native. And if you are a company and you would like to sponsor one of our events, please reach out to us. And for this edition, we have Chaos Native, that is an early leader in the open source cloud native chaos engineering, with intentions to further accelerate the pace of innovation as an independent company. They are working closely with users and maintainers of the LitmusChaos community. And LitmusChaos is it offers a complete tool set for cloud native SREs and developers to practice chaos engineering, and helps building the overall resilience of applications and platforms of the ecosystem. You can find more information regarding Chaos Native at chaosnative.com. And yeah, thanks for sponsoring the event today. We are really happy to to have the support. So you can reach out to us via LinkedIn or Twitter, but you can also submit a talk or a sponsor directly in that page. So we have a tiny URL link. Basically, if you want to talk, just go to CNCLinz -talk. And if you are a company and you would like to sponsor the meetup, CNCLinz sponsor. If you want to keep the conversation going on, even after the event, you can join our Discord server. Same tiny URL, CNCLinz-Discord, and you will get to the invite of the server. And finally, today's speakers, we have Karthik S, that is quality and automation lead at Mayadata. And in the second talk, well, he will go first. And in the second talk, we have Michael, that is founder at 10. And I guess he's more than a founder, but most probably that's what he's gonna talk about in his talk. Cool, that's all from my side. Thanks everyone, and have a nice meetup. Karthik, the stage is all yours.
Thanks, Giuliano. Hi, everyone. I think it's wonderful to be in this meetup. Thanks you again for inviting me for this meetup. I'm very happy to participate and look forward to a great discussion with all of you. Also looking forward to Michael's talk later during this meeting today. So myself, I'm Karthik. Thanks for the intro, Giuliano. I am a part of Chaos Native. Chaos Native is a new organization that has been spun off from Mayadata, and that happened very recently. In fact, just a week back. We are now working on providing better support for the Litmus project, which we've been primarily sponsoring for quite some time now. It is a CNCF sandbox project. In today's discussion, I'll just go over what is cloud native chaos engineering. We'll just touch upon that. I'm sure a lot of you have an idea of what it is. You might already be practicing chaos engineering in some form. So we'll just touch upon that. And after that, I'll talk about observability considerations in chaos. Observability is something that's very important, goes hand in hand with chaos engineering. Without observability, you don't really succeed at chaos engineering. So what the Litmus project is doing in order to provide better observability hooks and how it plays in this observability area is what we'll just speak about. I'll do a very quick demo without taking too much time. So that's the agenda for today. And with that, let me share my screen. I hope my screen is visible.
Yes, all good.
All right. So I've got a couple of decks here, a couple of slide decks that I've sort of used in different meetups or demonstration sessions. So I'll just alternate between the slides. We'll start off with what is chaos engineering, right? Chaos engineering 101 is very simple. You can see this schematic block diagram which says you constantly observe steady state on your system. You might be having some kind of a steady state defined already, how your application should behave, how your infrastructure should behave, what are its optimal operational characteristics. All that data is something that you already have in mind, and you define that as a steady state, and then you inject a fault. The fault injection is something that you do to vaccinate sort of your system. So chaos engineering is sometimes likened to vaccination. So you inject small doses of failure in a very controlled manner to see how your system behaves. What is the deviation that you see from the steady state? So this is what we call as a hypothesis, the amount of deviation that you expect from the steady state. How much time does it take to return back to optimal state, and what all happens over the course of that failure? All that is part of your hypothesis. So you hypothesize about the behavior of your infra. You go ahead and inject a fault. You observe what happens. If you are proved right, then that's great. You probably have to set the bar higher and inject another fault. But if something goes wrong, if you see that the behavior is not as per expectation, then it is a win because you've actually identified a problem and you have an opportunity to fix it. So you observe and improve and then repeat it. So chaos is not something, chaos used to be something that people used to do once in a while. It started off as practice that was popularized by Netflix. I'm sure you all know about Chaos Monkey, and that was the first real revolution in chaos engineering. And over a period of time, there have been a lot of tools and a lot of practices or culture around chaos engineering. It's slowly becoming a part of the DevOps culture, the SRE culture, and chaos was always associated as something that it was always associated with testing in production. So people used to feel that you need to run a game day, get all the stakeholders involved, create mitigation plans, and do the chaos in production and see how things are behaving. That's probably the most mature chaos engineering practice that you would find. It's almost like the nirvana of chaos engineering efforts. But with the introduction of the cloud native ecosystem and especially the microservice architecture, there are so many moving parts that you would like to do chaos even before you hit production, preferably so in your staging environments, pre-production environments. Chaos engineering is becoming more ubiquitous nowadays. Developers are also into it. They are using chaos as part of their dev test. So it's not something that you only do on production. You do it much before. That has in a way made chaos more democratic. It's not only in the sole domain of SREs, it's also something that others are picking up on a need basis. And it is something that needs to be done continuously. So this loop that you see, the control loop, needs to be executed continuously. Something that is being talked as chaos first principle in the DevOps world today. So this is about chaos engineering, and you may ask, what happens if I don't do this, and how is it really different from testing? Testing, functional testing and integration testing, system test, all are very useful, but there's a subtle difference between testing and chaos. In testing, there's a lot of how, that is, you're basically looking at validating the functionality of your application, but in case of chaos engineering, the what matters more. You have a set of SLOs that you've defined, and you expect your system to work under those SLOs. So whenever you're injecting faults, you're not really looking at exactly the functionality. Your goal is solely focused on whether the SLOs are being met, even under the chaotic circumstances. So there's a lot of overlap between failure testing and chaos, but there's the whole set of chaos principles. You can find all that information in principlesofchaos.org, which is a web page being maintained by the chaos community. Doing chaos continuously is a part of the chaos engineering principles. So you just need to be doing this feedback loop continuously, preferably as part of your CD pipelines. We are working with Captain to enable that, and that's something that's coming up quite well. So even if you're doing it manually, you might as well create a good schedule for yourself to be able to do this continuously and check how things are working. And one of the reasons why chaos, you might see a boom in chaos engineering, a lot of Twitter feed around chaos engineering, a lot of projects, tools in the recent times. One of the contributing reasons is Kubernetes itself. So Kubernetes is a very complex system. So you generally have your infrastructure or platform services on-premise or cloud. And then you have Kubernetes services running on top of that. Then you have all the microservices coming in from the cloud native ecosystem. You have things like core DNS, your service meshes, your DNS, monitoring observability systems, stateful storage providers. There are so many cloud native services that you're running as part of your stack. Then you have the important applications, the standard applications that you would find, and then ultimately your business logic. Things can go wrong anywhere, and that can impact your application in a big way, which is why chaos engineering is very important, and probably is more important in today's microservices distributed architecture world, where the surface attack for failure, the surface area for failures are much more. So this is something that is, again, talking about what we spoke about in the first slide. You identify steady state, you inject a fault, verify if the steady state is regained, or if your steady state is maintained in spite of the fault. If so, then you're resilient. Otherwise, you find a weakness, then go and fix it. What is cloud native chaos engineering? This sounds like a jargon, but it's actually a reality. So chaos engineering tools or the chaos engineering practices before this were not really chaos native. Either the tools were monolithic in their build, or the way you did chaos was not so cloud native. So when we say what is cloud native, it involves a host of paradigms around the way of doing things. Everything is declarative, everything is in a YAML, and implicitly, when you say cloud native, you're sort of meaning that you are having something to do with Kubernetes. And it also means that you're storing everything in a Git repository. You have a single source of truth, and you're doing everything from there, right? And everything that you associate with a particular act, either you deploy applications or you run chaos on it or you do auto recovery, all that happens in a very declarative way based on some properties that you define in YAML files. So that's one definition of cloud native. And when we started Litmus as a project, and I'll sort of interchange between the general chaos engineering practice and chaos engineering philosophy and Litmus. So Litmus was started for the chaos engineering needs of a project called OpenEBS, which many of you might be aware of. It is a containerized storage solution for Kubernetes. And when we started chaos for OpenEBS, we felt that it's not something that the OpenEBS test teams should be using. It's something that the users or the consumers of OpenEBS also should be using to test, their own environments. And if we had to enable that, then we had to provide the same kind of user experience or the same kind of interface that they're already using with the rest of their environment. That is, they're using OpenEBS as custom resources, and they're also using Helm charts for all the other applications, stateful applications that they are deploying. We wanted to have a similar experience for doing chaos as well. That's when we decided that let's put all the chaos intent in a custom resource, and we have an operator to reconcile it. And it also lends itself into a model where you store it in Git and you deploy it on your cluster. You can have various triggers for your chaos. For example, when you deploy your application change on the cluster, you can also choose to do chaos at the same time to see whether it's really stable. All that's made possible by a custom resource driven approach to chaos engineering, which is what we termed as cloud native way of chaos, which is how Litmus as a project developed. This is just a small update on the Litmus community. It's a sandbox project. It's got maintainers from different organizations, and there's been a good amount of usage and adoption. The core of the Litmus project or the Litmus framework is essentially the CRs, and there are different CRs for different purposes. The chaos experiment is what is the central piece, which you will find on the chaos hub, which is an open marketplace for doing chaos. You'll find all the experiments. Most of the experiments are under the generic category. Things like pod delete, resource chaos, network loss, node level Kubernetes chaos, etc. All that. So you will find them as custom resources that you can pull into your cluster, that you can install in your cluster off the shelf. And there are other resources which help run the chaos. Chaos engine is a CR that helps you to bind an application instance with your experiment, which you've already pulled from your chaos hub. You also define how you want to run it, whether you want monitoring enabled, whether you want to retain the chaos resources after you run the experiment, or you remove it, and all that. Result stores information about the experiment status and its verdict, and a schedule repeats your experiment. This is how your setup looks on the cluster. So you pull the chaos operator and the CRDs, and then you have the chaos resources. So when you create the chaos resources, the experiment is launched via some pods. The experiment are executed as jobs, and then the result gets stored. And you have some metrics exporters that are actually parsing the chaos result and providing you Prometheus metrics. And this can be installed via a Helm chart or a kubectl manifest. So this is a very brief introduction to Litmus. In recent times, we are also providing a UI. It's called as a Litmus portal, and it actually helps you to act as a single control plane for chaos on one or more clusters. So you can actually connect different clusters as target to your portal, and you can run chaos workflows, which is essentially one or more chaos engines embedded as a scenario. Sometimes you want some chaos to be injected in parallel, sometimes you want it in sequence, sometimes you want a chaos to run with some other benchmark or load jobs. So I think you will be able to do that using the chaos workflows, and all the information about these particular workflow runs can be found in the portal. I'll do a very quick demo where I will inject chaos using the portal. So this is something that's in beta today. The portal will become GA in a couple of months, but this is the new feature that we've introduced in the Litmus project. And the aim is to simplify the execution of chaos. All right, so this is about chaos engineering in general, and what is Litmus? It's a cloud native chaos engineering project, and this is how it works. This is the basic architecture of Litmus. What we are more interested in today is observability considerations in chaos, right? I can briefly talk about it. So observability is very important, and one of the reasons is when you do chaos, you want to see how your app is behaving, and you will not be able to do that if you don't have the right observability infrastructure in place. So all of you must have Prometheus, Grafana, or you might be using Neural Lake or different platforms, or you might be using Dynatrace, Datadog. You might be using a lot of platforms which allow you to visualize what's happening to your applications. And observability ties in with chaos in two ways. One is very interesting, the first one. It is chaos. There's generally a lot of entry barrier for chaos. That is, a lot of organizations don't want to start doing chaos engineering. They're very apprehensive about it. But you can actually pitch chaos as a means to test your observability infrastructure. That is, let's say you want to find out if you're getting the alerts and notifications correctly. You want to see if your incident response mechanism is all working fine, if the automation is all good. So you can actually use chaos as a means to inject some failures in your system and see if it's being reported correctly. So that's one very nice integration you can have. The other is the more standardized one, using observability infra as supportive tooling to visualize chaos and validate the hypothesis about application behavior. So when we say this, we have hypothesis typically involves two things. It may involve more things, but primarily involves two things. One is defining steady state. You should first know how your application behaves under optimal conditions, how it is generally expected to behave. And then what is the expected deviation when you inject a particular failure, and how much time it takes to revert to optimal operating characteristics, and how much time it takes to detect it, MTTR, MTTD, all these values. All that is part of hypothesis. Now, let's take a closer look at this steady state. So steady state is something that you can define in different ways. The golden signals of SRE come to mind: latency of your application, the number of errors, error count or error rate, your performance characteristics, saturation. All these things are indicative. They may be a good way to define steady state. They are the pillars of steady state or the parameters of steady state. But in recent times, there are other things that also qualify as steady state. I'm calling them as auxiliary indicators, but it is also as important as the others. For example, if you have some downstream services, then their availability, if you're running the stateful component, then checking the database health and checking the data integrity. And in case you're using applications that are being managed by operators, for example, you're using a Kafka operator, a Cassandra operator, and things like that, you have large CRs having a lot of fields in the statuses reflecting the health of your application. So you want to query that as well as part of your steady state, as part of your experiment run when you're doing chaos. So an experiment is the whole lot. It's not just injection of chaos, right? It involves steady state definition, validating that steady state, and checking for the impact or the blast radius. All that is part of the experiment, and Litmus enables you to do that. And these steady state parameters often tie into what we call as the SLOs or the SLAs. These are terms that are used in different varying meanings for different organizations, but generally this is what actually makes up your objectives, service level objectives. So with respect to Litmus, as far as observability is concerned, we have two ways of looking at it. We provide the right hooks to observability platforms to enable visualization. That means we provide chaos metrics, we have chaos events, and then we have all the logs that are descriptive and verbose about what's happening in your chaos. So that is basically trying to tie into observability, what these metrics are and how you can use them. I'll just talk about it in a second in a short demo. The other one is we are also able to consume observability information from the environment. That is, I can actually factor in metrics from the outside and use it for SLO validation. Not just generating metrics, we're not just generating metrics that you can use to visualize in your dashboards, but we can also gather and record observability information that's out there in your environment and factor that in to basically do the hypothesis validation inside of your experiment. And eventually that will result in an experiment verdict. Depending upon whether your expectation was met or no, you will get a success or a failure verdict. So this is what we do. And I'll do a very quick demo right now. I think I have about 10 minutes, so I'll probably make use of the time to do a demo on the Litmus portal to just explain what I was talking about. Let me go to the portal. I've got a couple of things on chat. There's a question that I can take immediately after the talk. Yeah, thank you for asking the question. I'm just going to hide my floating controls and go to where my portal is residing. Yeah, I have a portal here. This is the portal I was talking about, and this is what enables or helps you to run chaos experiments. I've got some experiments that I've done already. In this case, let me do a very quick test and show you what I mean by generating observability info and consuming it. Before that, let me explain the demo setup to you. This is the demo setup I have. It's a GKE cluster with 3 nodes, with a few nodes, and I've got the Litmus portal with all the control plane microservices installed here. I've got monitoring in terms of Prometheus and Grafana, and I've got a Kafka stateful set cluster. As part of the experiment, I will be generating some load. I'm going to create a test producer and consumer for Kafka that's actually going to generate some load. It's going to create a single partition topic which is replicated across 3 Kafka brokers. I have 3 Kafka broker pods running here. As you can see on my Linz setup, this Kafka 0, 1, and 2. I'm going to create a test producer and consumer. It's going to have a single topic with just a single partition, and the partition is going to be replicated across all these Kafka brokers. And I'm going to kill the leader partition, the leader broker for this particular partition. We're going to identify that as part of the experiment and kill it, and then that's going to trigger a failover. a new Kafka broker is actually going to pick up the partition leadership. And this is actually going to impact the message timeout on the consumer side. And I'm going to hypothesize about the message timeout. I'm going to set a particular value and see if that is sufficient. And the message stream is unbroken when I do this failure. If it is less, it's actually going to fail, right? And if it's good enough, then it's actually going to go through. And in this process, I also have a Grafana dashboard that I've set up using the JMX and Kafka exporters. And I'm going to see a chaos as it happens. There is an indicator that's basically an annotation that we've added. As you can see, there's a Litmus annotation. It's going to show up when the chaos happens, and when that during the period of chaos, what happens to the broker count, what happens to the under replicated partition count, and the bytes, etc. We can just take a look. Okay, I'm going to use the portal to launch the workflow. I'm going to schedule it on my cluster. I already have a predefined workflow manifest, so I'm just going to upload it. It's called the Kafka workflow manifest. And this is how a workflow looks. I can probably show this once again after we are done with the other discussions in the meetup. I just don't want to spend too much time explaining this YAML. I've got 75 seconds worth message timeout, which I think is a lot. So I'm expecting this to go through without the stream being broken, right? So let me go ahead and run. So this is basically some points or weight that you can associate with your experiment. If you have multiple experiments in a workflow, you can provide different points or weights to as per the criticality of the experiment, and your eventual resilience score, which the portal provides to you at the end of the experiment run, the workflow run, is going to be calculated keeping these weights in mind. I just have one, so I'm just going to provide all the points to it. And I've just launched the workflow. The workflow can be visualized like this. It has some steps. It's first going to pull the experiment CR from the chaos hub that I showed you and install it on the cluster. And then it's going to create the chaos engine that's mapping the experiment CR with the Kafka stateful set instance that you see here. And I'll also show you the activity that happens on the Litmus namespace. Okay, so you can see namespaces default Kafka as well as Litmus. So you can see some pods that are getting created here. These are the pods that are executed to facilitate the workflow run. And I've got the experiment pod that's got created. You can see the experiment runs as a job. And this experiment is now going to launch a liveness pod here in the Kafka namespace, which is actually having the test producer and consumer. And you can actually take a look at the logs for this. And logs for this, I'm going to look at the consumer. It's a very simple message stream. I'm going to print some information here and timestamp. And at this point, you can actually see one of these Kafka pods is being deleted. You can see that it's actually going down. Kafka 1 was the partition leader for this particular topic, and it's actually going down. And in this process, I don't want the message stream to be broken. I want it to continue with the timeout that I've provided, which is what I'm going to test now, which is what I'm going to look at. That's the hypothesis. And at this point, you can actually see the Grafana. There is this red bar or area that's coming up in your Grafana that indicates that chaos is in progress. And since one of the brokers is down, you will see that there are a lot of under-replicated partitions. One of the brokers is down. All of them need three brokers to be there. So you'll see a lot of under-replicated partitions. You'll see that the bytes have gone down. The message is stalled for the time being, so there's actually no traffic, so it's gone down. And the broker that was killed also happened to be the controller broker. That is the one that actually facilitates this failover and gets all the information from Zookeeper. So that was down, so you don't really see any information here for that period. Eventually it has recovered, and you will also see this value getting back to 0. That means all partitions will have their replication status come back to good state, and you can see the thing continues here. If I go to Linz, you can see this actually continued after an initial break. It continued to stream, so it tolerated the timeout that I provided. So the moral here, or the point that we were trying to make, is by generating the right metrics, Litmus is allowing you to achieve some kind of interleaving where, and this is not just for Litmus or for Kafka, it's for any chaos framework. It's good to provide metrics so that you can see what's happening with your application. You're able to interleave your app dashboards and gauge application behavior as you do your experiment. And also, just for completing the flow, let me take you to the Litmus portal. It's actually going to complete in another couple of minutes. It's doing a post chaos check. You can actually see there is a chaos result custom resource, and there's also chaos engine custom resource that we created. The engine custom resource actually has a lot of events that it's mapped against. The chaos result is actually the one which actually stores the information about your experiment run, whether it passed, failed, what happened to the various hypothesis probes that you ran. I'll just show it very quickly. Yeah, you can see that this experiment is actually passed, and the hypothesis was implemented as a probe. It's actually succeeded, and it has one passed run. You can fit in a lot of custom information into this chaos result as well. The other aspect of observability is not what we are generating, but what we are consuming from outside. For example, let's say my hypothesis was more than just looking for the message stream. Let's say I was interested in having 0 under-replicated partition before and after the experiment. That's something that I want to really check before I make my experiment succeed or call the verdict as pass. How do I do that? I can actually take the Prometheus queries for this, right? I have some queries already, and I can take those prom queries and add that into a probe within Litmus. I can provide the endpoint of the Prometheus. I can provide the query that I'm interested in. I can have a criteria for it, and I can define when it has to be executed. Before and after is what edge means. I can also have this as continuous. I can check continuously over the course of the experiment for a metric and see whether it's really meeting my hypothesis, whether it's lesser than, equal to, greater than something. And I can define some retry properties and timeouts for this probe. So what this means is we are actually able to consume observability data from the outside and use that as part of the hypothesis and influence the experiment verdict. And this is not just restricted to the Prometheus metrics. You can actually make it do anything else as well. For example, there are other type of probes. You can actually look at the status of chaos resources, custom resources, or you can look at other native resources in Kubernetes by a K8s probe. You can run commands. Maybe you can use your own CLI tool or library to run some commands and check integrity, for example, using command probes. You can also run HTTP probes to go get the service availability of other microservices or downstream services. And you can run them in different modes, beginning of the experiment or at the end or continuously, etc. So this is what I meant when I said you can consume observability information in your experiment, and all this is what we are also terming as declarative hypothesis. So you're able to actually state your steady state, you're able to define it and test it when you do the experiment runs. The portal also provides analytics. So analytics is generally not counted as an observability attribute. Generally, logs, alerts, and traces, metrics, events, they are the typical observability facets. But analytics is something that is also giving you useful information. So I just added that here. And the Litmus portal enables you to find out what happened over the course of the experiment, what happened to this experiment over a period of time. So you can actually go ahead and check what happened to it over a period of time. Maybe you improved your infrastructure, maybe you improved your application business logic. So what was failing earlier, you might have got a resiliency score of less than 100%, maybe 50, 60%, but you have improved it over a period of time, and all that can be gauged in the Litmus portal. So yeah, that was about the presentation really. I just wanted to talk about what is Litmus and how it helps with doing chaos engineering and what are its observability attributes. I hope this was a useful demo, and I think I can take some questions.
Wow, thank you, Karthik. That was really a lot, but thanks so much. We do have one question from the chat, and I also will have a question. Let's start with the one in the chat. So it goes, I wonder how it relates or compares to mutation testing. So how chaos engineering relates to mutation testing.
Yeah, I think that's a great question. Thanks for asking, Michael. I think one of the, at least if I understand it right, mutation testing also tends to be a lot lower level, very closely tied with your functionality or application behavior. Chaos is something that's done at a much higher level. You actually do random chaos against components that you might not really associate with that app directly. For example, I could be killing, for example, the node, right? Or I could be killing some dependent service which your business app is only making use of, but is not using it for functioning. Maybe I can say an observability component within your stack. That is important for your end customer. It's important for him to know what's happening, so that qualifies as a valid chaos scenario, but it might not be telling anything about the application behavior itself. So it's basically something done at a much higher level. Mutation testing, I think, is probably still at a lower level and very, very specific. Chaos can tend to be very generic, very random, and it's probably done at a much different level than mutation testing. I hope that sort of answers.
Thank you. That was, I mean, I had that in mind. That is basically just like the different levels. And I have a friend who is like crazy about that, and he built a library in Ruby, but so it's more like really like more an evolved version of testing, right? Where you just throw all the combinations of parameters at a function and see what happens. While as in chaos, you really hit the application, the service basically.
Yeah, the end SLOs that you might have promised to someone is what always remains your focus during the chaos experiment. It's not to say that chaos cannot be used to check low-level app behavior. You could do that. It's possible to tune a framework to get those kind of things done, but its objective is slightly different.
Okay.
Thanks. Are there any questions also from the community? Feel free to just unmute and ask the questions right away.
Yeah, I have a question. The test that you ran right now was specifically programmed to kill exactly that one node, that one pod. Would it be possible to create those chaos tests rule-based, like kill every one pod one after the other and stuff like that, and be aware, be sure that all of the different scenarios are hit without having to write them all manually?
That's again another great question. Thanks, Matthias. I'll probably take the help of the Litmus documentation to answer that question. You're right. This experiment, whatever we ran now, is a very, very specific test or experiment, which is listed under the application chaos experiments. So in the Litmus hub, you will see experiment of different categories. There are generic experiments that you can use. It's called pod delete. So you can run it on any experiment in any order you want, random selection of pods and all that. This comes under the Kafka category, where it has a very specific use case that we're targeting. To answer your question more specifically, yes, if you actually look at the experiments, for example, if you go to pod delete, you have certain environment variables, like where you can select the target pods you can either provide a comma-separated list, or you can do a random selection via pod effect percentage, where you can select a percentage of pods amongst the total number of replicas that you have of your application, or the replicas that have been filtered based on the app rules that you gave. And you can define a sequence. You can kill all of them in parallel, or you can kill them one after another serially. And yeah, there's a lot of tuning that you could do, a lot of randomization that you can do in the generic experiments. But you can also choose to make an experiment with a very specific purpose, like the way we did. We killed that one pod which happened to be the partition leader in amongst the Kafka brokers. That was deliberately done through the experiment business logic, but you can choose to randomize it by picking the generic pod delete experiment and tune it according to the way you need. In fact, the probes that I talked about, and the workflow, not just single experiment, but the workflow mode of running your chaos, combined with the probes, can actually give you a lot of permutations and combinations, and enable you to hit different scenarios, different corner cases. I hope that.
Yes, thank you very much. Answers it completely. And I have a follow-up question. And where in the development process would you place those kind of tests? So would that be something that runs every day on the CI pipeline, or is that something that you trigger specifically to find certain problems, or is there a regular element to that, or is that something that's a one-off thing that you do once and you have a partner that helps you for that?
That's a good question as well. So this has evolved over time, I would say, Matthias, and that's something that we captured in a blog that we jointly wrote with Captain team, with Jürgen. So you can find that information in these blogs, evaluating residency with Captain and reflection on the past 6 months, mostly the trends that you just spoke about. Chaos used to be something done in prod, and it used to be done in staging, not really tied with your app delivery lifecycle, but now it's changed. It has become ubiquitous. It's part of the latest concept is run chaos everywhere. In fact, people are running it in dev test, and we actually have an integration with Octeto, which is another project you might know, which is basically trying to help with improving your development cycles on Kubernetes, and we've actually enabling you to run chaos while you do this on Octeto Cloud. So which is essentially a developer flow. It's not even into your CI pipeline, it's even before that. So you do a lot of exploratory testing as you are developing. And then when you get into your CI pipelines, there are a lot of integrations that are available. For example, you can use Litmus GitLab remote templates. That is, it's going to look something like this. It's going to be an extension of your standard GitLab templates, but you source it from a different location. So this is in CI chaos is something like you build a transient cluster, something that's going to live for the duration of your CI pipeline. You put your application with the image that you just built, and then you go ahead and test it for some basic needs. The hypothesis and the flow of the experiment and what you're looking as outcome, or your return that you're looking for this experiment, might be slightly different from when you eventually run the same experiment on production or as part of CD pipelines. So Litmus also has an integration with Captain, where you actually run it in CD pipelines. That is, you finished your CI, you deployed it in a staging environment. Now you are doing some kind of validation before you promote it to prod. Right. So chaos, the framework will allow you to do chaos at all stages. But what are the experiments you do? What is your hypothesis at each stage? What are the probes you use? And what is the extent or blast radius of the failure? That kind of things can change. And it will help you to decide whether you really need to put this application in production. In fact, there's also the process of automating experiments to be done on prod as part of remediation procedures, etc. That's being talked about as well. So yeah, chaos is something that it has become ubiquitous now. You do it at all stages, but it depends upon what is the intent of the experiment at that point.
Thank you very much.
Karthik, I have a question. Maybe super easy to answer. You have shared the hub, the Chaos hub, and that was super cool. I want to ask you, how much do I need to configure from something that I get from the hub? And all the environment variables that I can set is usually in the way that you have shared with us in the previous one answering Matthias, that you have like everything in the description file, super simple like that, or yeah.
I think the manifests that are available on the hub, there are 2-3 manifests. One is the actual experiment CR, and that is something that you can pull as is. They are not really expected to be modified. For example, when you go inside pod delete, for example, you have this chaos experiment, so you can just apply this as is, right? That's like a skeletal bare bone CR with the minimum tunables to run pod delete. But the other CRs, for example, the chaos engine, there's an example that has been provided here. It's a sample. That's why we don't have a kubectl apply command for it. We just have an example put up here. So you can actually go and see what is the application you want to tie your chaos to. In my case, I'm giving you an example of an Nginx deployment on my default namespace, but that's not what you might want to run. So Chaos Engine is actually the user-facing CR. So this section might actually might need changes according to your use case. And this is also a very simple engine, doesn't really have the probes and all that configured in it. So that's something that you would do on a case-by-case basis. But the experiments and as a service account associated with the experiment is something you just pull off the shelf from the hub. So the engine and by extension the workflow is something that you would create based on your use case. And there are some tools which actually are getting built to help you construct this. There's a Litmus CTL, and the workflow, for example, can be constructed from the portal as well. For example, I can choose my own workflow creation, and I can choose the hub like this, select an experiment that I want to run, let's say pod delete, and then I can go and provide some information here, fill in the information. Right now, it's filled with some defaults. You can change it to your application, and then eventually come up with a workflow that you can always go and edit and save and commit back into your Git repository and use it in subsequent runs. There's also a CLI that will help you to generate that workflow. But yes, to answer your question, the experiment is something that you can pull. The workflow and the engine is something you tune on a case-by-case basis.
Awesome. Thank you very much.
Cool. Are there any more questions? I think we've consumed a lot of time. Maybe we can go ahead with the next talk, and I'm around for the meetup duration. I can take questions after the call or on chat as well.
Cool. Thank you so much. It was really great. Thanks also everyone for the questions. I shared 2 links also in the chat that Karthik mentioned. It's the one where we did some joint collaboration between the project I'm working on and also the LitmusChaos projects, and the blog post that Karthik wrote on this topic that he also talked about. So the links are in the chat. I guess, Juliana, we take it to the next phase, next step with our infamous icebreaker questions. I can share my screen really quick, and I will try to, or maybe Juliana, can you share your screen, and in the background, I will set up the breakout rooms.
Yep, I can. Give me 1 second.
It's the same format as last time, if you already joined last time, but Juliana will explain it. Can you reload it once? Because I just, I removed some questions because we don't need 5 rooms. Yeah, here we go. Okay. It's only 3 rooms. I think that's enough for today.
Cool. So basically, we're gonna have 3 rooms, 3 breakout rooms from the group that we are now. So we have 11 in total. Each room will be randomly, each person will be randomly assigned to one of the rooms, and every room will have a title, either for one of those bold words here. So room 1, the idea is to discuss what's your favorite place of all places that you've ever traveled. The room 2, you can only eat one food again for the rest of your life. What would you choose? And room 3, if you could hang out with any cartoon character, who would you choose and why? So basically, as you can see, it's really icebreaker questions, and it's just to interact with each other and yeah, have a little bit of fun. The breakout rooms are not recorded, so yeah, you can open yourself, but of course you don't need to talk about, you don't have to be 100% honest. You can just say whatever you like. And we're gonna do that for 10-15 minutes, right, Jürgen?
Yes. So cool. Since we took a little bit more time for Q&A, which we totally like, that we have so many questions, because that's also what the meetup is about, that you have all your questions answered. But I will set maybe a timer for, let's say, 12 minutes. So we have something like, you will see it in the room anyway, and then we will come back to the main room. Usually you only have to kind of accept this breakout room, and it should bring you back to the main room. Please do not leave this session, but just kind of accept that you are taken back to the lobby or to the main room afterwards. I will open up the rooms. You will be assigned randomly, and I will join the room that has at least attendance, because we cannot divide 10 by 3 without something after the dot. So see you soon in a couple of minutes. Does it work? Yeah, it looks like it's working. Some automation kicked in to bring you all back. That's great. Yeah, Matthias, you were just telling me that there should be another way of broadcasting these messages, but I could not find it, and in the chat it only allowed me to chat with the 3 of you in our room. But it looks like we brought probably everyone back. Yes, I think everyone's back.
There's some lost souls in the breakout rooms.
It does not say that there are still rooms open, so hopefully everyone is coming back. Yeah, and with that, yeah, please also share your feedback, how you like this kind of breakout rooms. If you think it's a wasted time, then let us know. If you like them, then we will keep doing this. We just thought it's nice.
I will never come back to this meetup. Sorry, you had your chance. First and last one.
Now it's your chance, Michael.
Okay, yeah. Oh, I cannot leave now. I mean, I was supposed to give a talk, but after this.
Yeah, but now it's really your chance. We just hand over the stage to you, and maybe just as a kind of an introduction, So Michael will be talking about his journey on building a platform, a writing and editing platform in the cloud. And we agreed on the format that he will do a little bit of presentation, but not like everything will be presented from him to us, but we try to make it very interactive in the second half of the presentation. So if there are any questions, please write them in the chat, or just later on when we open up all the mics, or if you want to open up the mic, then just ask him questions and we try to discuss. And it should be kind of a knowledge exchange.
Yeah, exactly. So, I mean, basically, even if I'm in the middle of it, you can just chip in and turn the microphone on and ask. I think, yeah, that's basically, I'll just, show my experience. As Jürgen said, like wait, let me first just start my slides so that this is done.